Unit 1, stuff you're going to be actually like tested on the AP exam, starts now. Now, Unit 1 is very important theoretically for the future of this class. Now, if you like don't do well answering the questions, but you understand the concepts that we're about to introduce you to, like limits, that's what's important coming out of Unit 1. All the stuff we'll do, the questions that we're going to answer, really doesn't like stay with us. It's going to help us introduce the important concept of Unit 2, and then Unit 2 is really where like the class really starts. You've seen these 3 lessons in Unit 1 before, but I'm going to reteach it to you pretending like you never saw them. Cool? And we're going to learn calculus. Calculus is the math of change. We'll talk about how things are changing. Quickly, not quickly, increasing, decreasing. We're going to talk about the change of change. Another thing they call calculus is the math of infinities. Or, and this is kind of important with today's lesson, the math of infinitesimal. What do you think an infinitesimal is? Tell your tables. What's an infinitesimal? What do you think? I heard it over here. A really small number. Small. Infinitely small. Okay? That's important with today's lesson. Thinking about something infinitely small, infinitely close to. All right? 2 major problems solved by calculus that seem to be like straightforward, just like very math problems, but like what they actually mean is a lot greater than what we think it is. We'll find a tangent line anywhere on a curve. We'll tackle this problem in the first semester. We'll learn about the word derivative. Derivatives. You'll learn about a derivative Unit 2, lesson 1. We won't learn about that until Unit 2. And then the second semester, we'll tackle this major problem, which is, hey, what's the area under this function? Can't use geometry because there's no equation for this shape. We'll have to use something else. I'm going to use integrals. You don't know what an integral is? We're not going to know what an integral is until the second semester. Okay? But we'll find like the meaning to these problems are a lot greater. Calculus can be applied to a lot of different fields. And we'll see that like these 2 things we're going to handle, like actually can apply itself into a lot of places. But before we tackle those problems, we're going to talk about limits. Limits are the building blocks of calculus. I'm still over there. Oh, you guys don't have limits. All right, whatever. You don't need it. Okay? Say, lesson 1, we're learning about limits. Now, you're not going to see the word limit for like the first half of like the notes. Okay? What we are going to see to help us understand limits are piecewise functions. Oh, goodness. Now, good thing to know is that this whole graphing, which freaks you out because you don't have a calculator, you don't really need to know how to do. It might help us, but typically you'll like be given a graph and be asked like, hey, what do we got here? Okay. So like we're going to answer these first 5 questions without graphing. I'm going to graph it afterwards. Okay, we have this function, f of x. It's important to know it's like we got inputs, like we are going to take X values, which do show up graphically on an X axis. It's like our input axis. These are the numbers that we take and we plug into a function. And then after we plug them out, we'll get these Y's, or outputs. If I ask you to find f of 1, f of 1 is an X value. Now, if this was just like f of X equals 3x plus 4, and I ask you what is f of 1, well, you would just plug in 1 for X. You get 7. So like f of 1 would be 7 for this situation up here. But having a piecewise function means, depending on which X we plug in, we'll use one piece or another. So important to realize before we just start plugging in, what are our pieces used for? We got this X plus 3 piece. So I'm going to take my inputs, add 3 to them for all X's that are less than 2. And then we got this negative 2x plus 5 piece that we'll use for all X's bigger than or equal to 2. So it's important before we do anything to realize, oh, 1 is an X value that's less than 2. I will take that X value 1. I'm not going to plug it into both because I'm only told to use that piece for X is less than 2. So I plug in 1 to this piece. I get 1 plus 3. That's 4. Boom. If I'd like to, you could graph the point 1, 4. But you don't have to. Now we look at the next question, f of 2. All right, well, 2 is an X value that's greater than or equal to 2. It's equal to 2. So that means I'm going to use the second piece, negative 2x plus 5. I will take that 2, plug it in for X. I get negative 2 times 2, which is negative 4, add 5, and I get 1. So at 2, I could plot the point 1. 3 is an X coordinate that's bigger than or equal to 2, which means don't plug it into both. Just plug it into the bottom piece because we are only allowed to plug in 3 for that piece, X that's bigger than 2. I get negative 2 times 3, which is negative 6 plus 5. I get negative 1. All right, and if you want to, you could plot the 3, negative 1 point. But now I have a question. Like, what if you plugged in 1.999999999? Repeated, but eventually we'll stop, Like, maybe we have like 59, okay? And then you plug in 2.00001, okay? Now, we know that this number and this number are very close to 2, right? But this one's less than 2. This one's more than 2. Okay. So, what do you think, guys? What should we plug in? Should we be intimidated? We're not asked what we're equal to. We're asked, like, what are we going to get close to when we plug it in? Tell your neighbors, what do you think you get for f of 1.99999 and f of 2.0001? Go. Talk. What are the y values we get? Now, the reason why we collapse is so that you're in these tables so that you can talk, okay? So that you can kind of like feel comfortable not getting the right answers, but like trying, Put yourself out there, give it a shot, Okay, I usually ask questions. I don't really expect answers, but I do expect communication. Okay, collaboration. You got 5 people here. Okay, you can check. You can throw an idea off of somebody and be okay with like being wrong. You just got to try. Now you might be thinking, oh, that's like 2, but it's not. It's a little bit less than 2. This is a number that's less than 2. So I would plug in this number into this piece, the top piece, the x plus 3 piece. Now, you might be thinking, oh, okay, 1.9999 plus 3, that's going to be like 4.99999. But like, that's what I'm asking you. I'm not asking you like what it equals. I says, what is it close to? Like, what is it approaching? And it's good to see with your calculator sometimes. Like, your calculator eventually will say, yo, Mr. Messner, you plugged in so many 1.9999, you're pretty much telling me you're plugging in 2. It eventually gives up and it rounds. I put in so many 9s after that, the calculator's like, nah, that's too many 9s. I'm just pretty much plugging in 2. Well, that's what you can think of. You're pretty much plugging in 2 here. You're adding 3 to it. You're getting close to 5. That's the answer that I'm looking for, not 4.9999. I'm asking you, what are you getting close to? What are you really close to? Infinitely close to. Cool? And this is the idea behind an open circle on a graph. Well, I'm going to get really close to the point 2, 5. But I'm never really going to get there. I'm going to end up with 4.999999. I'm going to approach, but not get to this 0.25 on this red graph, the x plus 3 piece. I end with an open circle because I never get to the 0.25, but I get really, really close to it. And if I go the other direction, well, it already makes sense. Like, this is still bigger than or equal to 2. I will use the blue piece. I will think about plugging in 2.00001, but we know that like that's essentially plugging in 2. And when I plug in 2, I get -4 plus 5. I get -1. What is it equal to? Yeah, sure, it's like -1.00001 or something like that. I don't care. It's getting close to -1. Cool? +1. Sorry about that. I'm all on concepts, not actual answers. All right, your turn. Go ahead and try these 5. And if you're wrong, it's okay. We're trying. It's good to make mistakes. If you're making mistakes, you'll know how to then like fix mistakes. If you never make a mistake, then you're just gonna like hope that you'll get things right all the time. But nobody gets things right all the time. Do you know? Now, you don't have the graph. If you don't want to do the graphing part on the right side, don't do it. I'll do it. You just get the right answers for the 5 questions. G of 0, G of 1, G of 2. G of 0.9 repeated is going to be approaching this Y value. G of 1.001, like 0 repeated followed by 1, is going to get close to this. Okay? And go ahead and check. All right. in hindsight, I probably would have picked a different number than 2, but you guys picked 2, so we'll go off of that. But I probably would have picked like 3 in hindsight, because I never like to get the same number twice when they come from different places. So 3 situations. X is less than 1, X equals 1, X is greater than 1. 3 different colors here. 0, less than 1. Plug it into the top piece. You get 3. 1 is equal to 1. Use the middle piece. Oh, you just get the y coordinate 6. 2, I'm going to change it to 3. If you don't change it, no big deal. But I just want to get a different number. If I plug in 3, 3 is bigger than 1. I will plug it into the bottom piece. 3 plus 4 is 7. I just like getting different numbers like that. All right, now to the important question. What if I plugged in 0.9999 repeat? Well, this value is close to 1, but it's less than 1. A little bit less than 1. So I would plug it into the top piece. Now, if I plug in 0.999 repeated, it's essentially like plugging in 1. If I plug in 1 into this top piece, I get 2, negative 1 plus 3. Now, I really get like 2.0001 repeated, but again, I'm saying, what are we getting close to? What number are we very, very close to? Well, we're close to 2. Now, if I plugged in 1.00001, this number is a little bit bigger than 1. So I'm going to be using the blue piece. If I plug in that number very, very close to 1, it'll just be like plugging in 1. I get 5. Don't add the point zeros. I'm asking you, what are you getting close to? All right, now if you were to graph this, what you will find is that we got, the 0.03. We are getting close to the 0.12. Maybe I'll move up 3, but no, we'll stick with it. We got 0.3. We're getting close to the 0.12. You got a straight line. Who cares? We have the 0.16. Close circle there. At 1, we are using the y coordinate 6. And then we will be approaching the 0.15, but we'll be going up from there. Who cares what it looks like? Let me fix it. Monday morning slate issues. There we go. Going up from there, we approach 2. We kind of go down into there. Boom. Now, what we'll be asked to do is like get the same answers, but not have this. Like eventually, I'm going to say, hey, looking at this graph, can you tell me, like, if you're a little bit less than 1, what's the y value you're approaching? If you're a little bit bigger than 1, what's the y value that you're approaching? If you're at 1, what is the y value you have? Cool? Hopefully, that won't be too worrisome once we get there. To this one. Love this one. It's a great one. Talk about it. What do you think? Undefineds only happen when I have like a 0 in a denominator, or I'm not allowed to plug it in. All right, talk, check. All right. Seems like some of us are like, boom, we got it right away. Some of us are thinking about it. It's okay. That's exactly right, Tesla. Since it's not exactly -2, we're not going to treat it like it's exactly negative. Okay. So we got either equal to -2 or not equal to -2. If we are equal to -2, we'll use 1. If we are not equal to -2, that guy, this guy, and this guy are not equal to -2. Since these are not equal to -2, we got to use the top guy. We got to use the x squared. So x squared, a negative squared is a positive, 9. X squared, 16. This x value squared, again, it's not equal to -2, but it's really close to it. It essentially is it, but it's not. So what would this be? Well, think about it. -2.0001 squared, it's going to be just like -2 squared, which is 4. This value, yeah, sure, it'll have like a 0.00001, but what am I'm saying, what is it close to? What does it approach it? Well, square this number, it's going to be close to 4. Again, I plug it into x squared because that number is not -2. This number is not -2. Close to it, but it's not equal to it. You get 4 here. What we have is a situation where at -2, I use the point 1. Sure. But everywhere else, I use x squared. But I'm not using x squared at -2. But I'm getting very, very close to the value that we're approaching. We create this graph. We create what is like a hole and a point. If I say plug in -2.001, this graph shows you we're getting close to 4. If I plug in -1.999, this graph is showing me I'm getting close to 4. If I plug in -2, I get 1. That closed circle is showing you if you plug in -2, you get 1. Okay, that'll be important because soon I will just give you the graph and not give you this. Okay. I love this one. I'm going to actually do it with you. All right. Now, this is not a piecewise function. This is just a function. So it's like, okay, I will be plugging in all of these numbers into the x coordinates in J. Let's see what happens. Let's plug in 1. All right, well, 1 squared minus 4, that's -3. 1 minus 2, that's -1. -3 over -1, that's +3. Okay, cool. That's easy. All right, let's plug in 1.5. I don't want to do that. I don't want to multiply. I don't have a calculator. I'm going to skip that one. All right, let's skip that one. We'll come back to it. Cool? Cool? All right, let's go to 2. Plug in 2. 2 squared is 4. 4 minus 4 is 0. 2 minus 2 is 0. Ooh, I get 0 over 0. Now, we have not seen 0 over 0 yet in this class at all. I saw 1 over 0 in unit 0. 0 over 0 is very confusing to even me and very confusing to a lot of students. Some people think, oh, something divided by itself is 1. Okay? Some people think 0 divided by anything is 0. Some people think anything divided by 0 is undefined. Right? So like we have so many options. Turns out like this could be really anything. So it's undefined. We don't know what it is. This is very important to know and to like hold on to. 0 divided by 0 cannot be done. Can't do it. That means at 2, I'm not going to get anything. I'm not going to have a point over 2. Okay? Well, let's now try to plug in 1.5. Again, I don't want to square 1.5. I don't want to square 2.5. Like, that's going to be a little tricky to do. So, you know what I'm going to do? I'm actually going to rewrite J. Just because, like, I've noticed from my past math experiences in algebra that, like, this is a difference of squares and I can factor it. All right, why don't we rewrite this as x plus 2 times x minus 2. Now, hold on. Don't do what you want to do yet. Let's plug in 1.5. I wish I had more space, but I don't. Into this, rather than having to square it, again, I don't want to do like long multiplication if I don't have to. Let's just plug in 1.5 into that, because this is the same as this. It just looks different. So I get 1.5 plus 2. I get 1.5 minus 2 over 1.5 minus 2. Now, this is 3.5. Cool? This is -1/2. This is -1/2. Well, don't the negative halves just cancel, right? Because it's something divided by itself. Yeah, they do. So I just get 3.5. Great. All right, so I have that point 1.5, 3.5. All right, plug in 2.5. Not into x squared minus 4. We don't have a calculator. We can't square 2.5. So let's plug it into the factored form. Let's see what we get. Let's go through here. Gotcha. All right, so I get 2.5 plus 2. I get 2.5 minus 2, 2.5 minus 2 on the bottom. Okay, this is positive 0.5, this is positive 0.5, this is 4.5. Well, I could cancel the positive 0.5 there because it's just some number divided by itself. It's just a 1. So I get 4.5. Great. Now, let's think about plugging in 1.9 repeated. Okay, I'm going to just do it really quickly. 1.9 repeated plus 2. 1.9 repeated minus 2 over 1.9 repeated minus 2. Now, earlier, we discovered you can't plug in 2. Okay, because when you plug in 2, you get 0 on the dot, like equals 0 in the denominator. You are never allowed to divide by 0. Tell your neighbors, are you going to get 0 on the dot in the denominator for this one? No, you're getting something really, really close to 0, right? But is it equal to 0? No, but it's very, very close to it. So you can't plug in 2 still. Like I still can't plug in 2, 2 plus 2, 2 minus 2, 2 minus 2. I can't do this. It's still undefined here. But I could plug in something close to 2 because I won't get 0. I get something other than 0. And I get essentially 2 plus 2, which is 4. If I went in the other direction, it's the same thing. I get 4. What we've just created was this graph. A graph of essentially x plus 2, right? You want to cancel this and say, oh, j of x is just x plus 2. Well, you're right. J of x is just x plus 2 with one exception. There is an open circle at 2 4 because you are not allowed to plug in 2 into the original equation. You could plug in 2 into a simplified equation, but the simplified equation changes J. You're not allowed to plug in 2 into J, but you could plug in any other number into J, and any other number plugged in besides 2, just plug it into x plus 2. Does that make sense? It's a little tricky, this stuff. So we have a situation where we have a hole in a graph. We're approaching a y-coordinate 4, but we never really get to that point 2, 4. All right, we'll do this one. This is another function. It's not a piecewise function. Asking you to plug in a bunch of numbers. Go. Absolute value. What's special about an absolute value, Tucker? Now, like if I plug in a positive into an absolute value, what happens? It's a positive. What if I plug in a negative into an absolute value? Okay, good. That's all I need you to know, okay? If you plug in a negative into an absolute value, it turns into a positive. If you plug in a positive, you get a positive. Give me these 1, 2, 3, 4, 5, 6, 7 answers. Make sure the rest of your team has the answers. Okay, help each other out. Kubota, help your team. Ferial, help your team. People, how are we doing? They're all positive, but be careful. They're not all positive. Down, right?
Yes.
Help people out. Are you dividing by 0 here?
No.
You're not. It's close to 0, but it's not 0, so that means you can divide by it. Awesome. Wait. Calder. I don't think I would have gotten that call. I'm sorry. I'm working on it. Crumley? All right. If I plug in -2, the top turns into a +2, but the bottom stays as a -2, this is -1. If I plug in -0.5, the top turns into +0.5, the bottom stays as -0.5. This is -1 because something divided by itself is 1. I'm not allowed to plug in 0. I can't plug in 0 on the dot. You're never allowed to divide by 0. Even 0 over 0 is undefined. Very important. Plug in 0.5, I get 0.5 over 0.5. Okay, that's +1. Plug in 2, I get 2 over 2. The absolute value doesn't change it. We got a positive in the denominator. Okay, so we got a bunch of -1s. We got an undefined, and we got some 1. What if we plug in something very close to 0 that's negative? Well, again, yes, it's close to 0, but it's not exactly 0. So this would be like a positive number divided by itself. Yes, they're close to 0, but they're not exactly 0, so I can plug them in. And I do get -1. If I did the opposite side, well, it'd be the same thing, just the bottom would be positive and this would be +1. We just created what is called the jump function. Why is it the jump function? Because to the left of 0, we got just -1. As I approach 0, I'm staying at -1, but I can't plug in 0. Because if I plugged in 0, I got 0 over 0, not allowed to do that. So at 0, I don't have any points. But if I'm just to the right of 0, I'm up here at 1. I'm approaching that 0 from these +1. Cool. What you guys just answered, like what you guys understand using these like 0.999s and these 0.001s, is you showing that you kind of already understand the concept of a limit. Okay? A limit is a value that a function approaches. Okay? Limits don't care about function values at location. It cares about function values very close to location. Limits don't care about values at location. They do care about close to or infinitely close to. Okay? Now, here is notation we will use for limits. We'll use a lowercase lim, means the limit. As x, we'll use a little arrow. This means as x approaches, and then we will pick a number. If I put then a negative symbol above that number, this means approaching the number from the left. This is a left-hand limit. Left hand, that says hand limit. LHL for short. What we're thinking about is using a number just a little bit less than what we have. Like if the question was x approaches 2 from the left, you'd be thinking 1.9999. Okay, try to fit that all in. So I should have given you more space. Now, we will have limits as x approaches number, and then a plus symbol in the exponent. The plus symbol means from the right. This is a right-hand limit. RHL for short. That means you'll use a number just bigger than a number that's like f. Like if I have x approaches 2 plus, that means 2 from the right. That means think about using 2.0001. Now, you will also be asked limit questions, but without a plus or minus. This is what I'll call like in general. Now, the only way we can confidently answer to an in general limit, this is very important, guys. You're asked for a limit in general. You must check that the left-hand limit equals the right-hand limit. If the left-hand limit equals 5 and the right-hand limit equals 5, you will say the limit in general equals 5. I don't care about the function value. It's just the left-hand limit and the right-hand limit. If one of these disagrees with the other, this does not exist. An in general limit, you do not answer by just like looking at it or looking at like the location. You answer an in general limit by looking at the left-hand limit and the right-hand limit. If this number and this number are the same, that's your answer. Okay? Don't think it's something else. Very easy. If this is 3 and this is 3, this is 3. But if this is different than this doesn't exist. Cool. Now, we're going to go back to the same situation. I already have a graph. We can answer all of these questions either by looking at the graph or by doing what we just did, which was like plugging in into our piecewise functions, depending on like what we're using and which piece we're using. Let's see if you can answer these questions. Go. And if you're like, I don't get it, ask your neighbors. Here's where I'm starting. Let's stray on. Ready? 2, negative. I'm thinking 1.999. And then I look either here at 1.999, and I'm looking for the y value, or I'm thinking, oh, 1.999 would get plugged into there. And we'll get our answer 2 different ways, either by looking at the graph or using the piecewise expression. Cool? Go. You got the right answer. I think you just made the same mistake that I made. Good. Did you plug in or did you look at the graph? Cool. That's fine. Come on, try. If you're like, I have no idea, ask your neighbors. Great question. How do you do all the bottom? How do you do all the bottom? You're right. Yep. Yep. What's this? What's that? Oh, you got 1. Right?
Oh, that's not it.
Correct. Yeah, 5 is 1. Is this the same as this?
No.
No, it does not exist.
I thought you could do not exist if it's the same.
No, if it's the same, that's your answer.
Okay. Maybe I'm just tired. I don't know why.
It's okay. I didn't have enough space to like put all of it. So.
Okay, never mind.
There we go. Now we got some chatter. Now we're checking. Let me check back here. How are we doing back here? Yeah? Let me see. Good.
Are we gonna have the graph on the?
Nope. Isn't that great? Ah, thank you. Yeah, over there. Okay. It seems like everybody's cool with the top row. The top row is actually the row that is more confusing if you think about it. 2 from the left is like plugging in 1.999. We did that. We plugged it in there. We get 5. You can see on the graph, again, soon, very soon, we'll be just looking at a graph. We need to get that same information. If I plugged in 1.999, I'd be using this piece. This piece approaches the y-coordinate of 5 as I get closer and closer to 2. We'll need to get that without having the piecewise expression. If I'm looking at 2 from the right, 2.001, oh, that's bigger than 2. I'm using the bottom guy. If I plug in 2 here, you get positive 1. Again, you'll need to do that just by looking at the graph. From to the right of 2, I'm using this piece. Since this number does not equal this number, this does not exist. That's all you look at. You look at the left, you look at the right. If they agree with each other, that's your answer. If they do not agree with each other, that does not exist. If I were to plug in 2 on the dot, even though the limit does not care about this, you get 1. Now, let's look at 0. Well, at 0, to the left of 0, to the right of 0, at 0, you're right here, you're at this point. you have the value 0, 3, because you're using this piece for x is less than 2. Or students get confusing, that's why I always put this in here. It's like, don't freak yourself out. Negative 0.0001, plug it into this guy. 0.0001, plug it into this guy. You'll get your answer there from these two. At 0, plug it into that guy. 3 across the board. You get 3, you get 3. Since this number is the same as this number, that's your answer for this in general limit. This is very important. A lot of people mess up on that. And the function value is 3. All right, let's skip the whole 2s. Let's just worry about the 1s. So, like, I hope we know that at and around 2, we're using this piece. And I'm going to get 6 across the board. Okay? But that's not the interesting part. Let's look at and around 1. Go. We already have these answers down. We already wrote them down, but now it's just the same questions, just coming at you using different notation.
So, how do you tell, like,
That's 1 from the left.
1 from the left? So it's
0.999. Got that?
yes. And if it was 1 right, it would be. I put 1.1. 1.001.
Yep. All right, good. Now, again, we have the expression, but if we don't, we need to be able to get these answers by looking at the picture. Okay? You're not asked to graph, but you're asked to interpret graphs. 1 from the left, 0.999999. We're using this guy because it's less than 1. Less than 1, use negative x plus 3. It's like negative 1 plus 3. It's approaching 2. You can see that here at 0.9999, you're using this piece. The y value is approaching 2. At 1.001, I'm bigger than 1. I'm using this piece. 1.0001, we'd be using this piece. We are approaching the y coordinate of 5, or I'm plugging in 1, 1 plus 4 is 5. This does not agree with this. This answer, it does not exist. And at 1, this, again, I don't care about what I answered here, here, or here for this question. This equals 1. Since this equals 1, I use 6. All right. Let's see. Skip the 3s. Let's just focus on negative 2. Let's see if we get this. We got a different situation. I got a hole and a point. So far, limits don't exist in general. Skip the 3. Negative 1.999. Cool. Does that equal negative 2? Or does that not equal negative 2? Right?
Yeah.
So that's what you got to think of first.
Okay.
Does this equal negative 2?
No, it's close.
No, it doesn't.
Okay.
So since it doesn't equal negative 2, boom. That guy. Do you need the notes? Oh, yeah. I have extra copies. Nice, Dang. Everybody else got Dang's answers? Good. Yep. Good, guys. Very good. Awesome. Yep. Good. Good. So it's all about, do we equal -2 or are we not equal to -2? These first two guys do not equal -2. Now, really quickly, did you use the right number here and here? A lot of people put -1.9999. It worked out in here, but just think, if you are at a negative number, a negative number to the left would be more negative. So you should be using -2.001. That's like, everybody messes up on that once, but it'll help you if you fix this now for the future. Okay. This does not equal -2. It's close to it, but it's not equal to it, which means I'm using x squared. Square that number, it's close to 4. How do you see that on the graph? To the left of -2, I'm using this graph. This graph is approaching 4 as I get closer to -2. To the right of -2, same deal. I'm using this graph. It is not equal to -2, so I'm using x squared. I get 4. Because this number is the same as this number, that's 4. I don't care that at -2, we have this point -1. I don't care, 1. I don't care that h of -2 is 1. This has nothing to do with this. Got it? All right. I'm going to give you a couple seconds. I'm going to pause you. Pause. 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 Who factored this right away? Who factored this right away? Cool. Cool. Hold on. Hold on. I'm not done yet. Who then canceled x minus 2's right away? Okay, a bunch of you, right? Who then plugged in 2 and say j of 2 is 4? Wrong. 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 It's okay. It's a good mistake to make, though. What is j? J is this. J is this. What did you do? Give me a simplified j. This is different. I can plug in 2 into this, sure. But I can't plug in 2 into j. I get 0 over 0. This is undefined. It is. You're not allowed to plug in 2 on the dot. If you plug in 2, you get 0 over 0. So j of 2 is undefined. Cool. All right, now before we continue, remember what I said. If I ask you for an in general limit, you better at least think about the left-hand limit and the right-hand limit. All right, now continue. We should have a graph here just to show what's going on. That's what this graph looks like. It might help to see it. This is the graph of J of X. If you don't have it, you should probably put it in. I don't know why I didn't include the graph of J of X. Yeah. No, third line. That's the graph of J of X. What do you see? I don't have a point at 2. I don't have a point at 2. But I can plug in things that aren't 2. And if I plug in things that aren't 2, you can then cancel those x minus 2s. Because you're not going to get something that equals 0 on the bottom, but you'll get something that's close to 0. This is when we get 4 and 4. And this is when we have a limit, even though we don't have a function value. So heads up, guys, holes have limits. Holes have limits. This is a hole without a point. It's got a limit. It's equal to the y-coordinate, where the hole is located. This is a hole with a point. Holes have limits. What does the limit equal? The y-coordinate that we're approaching at the hole, not the y-coordinate of the point. Okay? The point is just like at this location. Limits don't care about locations. They care about what's going on just to the left and just to the right of the location. Okay? We can't cancel until we understand you're not allowed to plug in 2. After we understand that this is undefined, then go ahead and cancel, because any other number plugged in would not give you a 0 in the denominator. Does that make sense? Are we good with that? All right, last one, and then we go to a nice big picture and no equation. If you need a little like reminder, put it down. Holes have limits. They may or may not have a function value at the location. Why are we doing areas of circles over here? Oh, isn't that funny? All right, good. Why?
The puns are really bad.
No, they're hilarious. Look at this one right here. Calculus has its limits. That's what we're doing right now. Great. Oh, man. Good. All right. Help once people get their answers. Don't give answers. Help when things are asked for. Limits exist or not exist. Function values are defined or undefined. So I'd prefer you put DNE for that. Just like you did. Perfect. Chain 2. Hey, you didn't move it. Turn to Costa. All right, good. We just dealt with this one. We saw that if we plugged in 0, you're not allowed to plug in 0. You get 0 over 0. Exactly 0. You're not allowed to get that. That's undefined. Cool. But if you plugged in something else, you're allowed to divide by numbers other than 0. You'll either get a -1 or a +1. This number is not the same as this number, therefore the limit does not exist. Limits exist. This is important. Limits exist or they do not exist. Function values are defined or they are undefined. Okay? All right. Sorry, no more equations. Just a graph. No more equations, just a graph. No more equations, just a graph. Go. No more equations, just a graph. You need to get your answers just by looking at this graph.
Okay, so when it's approaching, that's for sure. But whenever each one is forward, then that's yeah, sorry. Sure, we catch you.
Good.
I've done it.
Nice. Mueller's right.
Let's go.
With what?
So this one would be like negative 3.99, right?
Nope. It's actually negative 4.001. Negative 4 is to the left of 0, to the left of negative 4. Okay, cool.
And then this one would be.
Negative 3.99.
And then and then how do you like find them on the graph?
Well, these are x values, right? Where do x values come from in our graph?
These ones?
These are x values.
Yeah.
Okay, so identify your x values location. All right, let's go to negative 4.001. That's an x value. Right there. Good.
Okay.
Now, what is the y value?
2?
It's getting close to 2.
Okay.
We are approaching 2.
Okay. That makes sense.
Okay?
And then this one would be 2 as well?
Yep.
And this one would be 2?
Because this and this are 2, this is 2.
Okay.
Now, what about at negative 4 on the dot?
It doesn't exist.
Exactly. There's no function value at that. Holes have limits, but they may or may not have function values. Here's a hole without a function value. Here's a hole with a function value.
Okay.
This is correct.
So then on this one, it'll be like the same thing, but then this one will be 2?
Yes. At 6, you have 2. But what about negative, 5.9999, 6.001?
You have 6.
6, 5.
So these ones are going to be 5?
Yep. You understand why?
Because it's like right here and then right here.
Yeah, exactly. And what's that? That's really close to 5. Exactly. 10 years. And I'm still making things better. This is a new lesson this year. Because I'm like, I didn't teach limits well enough last year. Yeah. Well, the lessons we had in pre-calculus, made me make this better. So you saying you think you understood things? We didn't do matrix B.
You really have your limits.
I told you you're going to be seeing it. All right, ready, guys? Here's the way we could think about it. This piece is used for all x's that are less than or equal to 1. You see that point at 1, 4? That's telling me I'm using that piece at 1. But I can't plug in negative 4. If I plug in negative 4, I don't have a value. There's no point associated. Here, this piece is used for all x's bigger than 1, because I start with this open circle. However, when x is 6, I don't use this piece. I use this point 2. That may or may not help you. Let me give you a couple more seconds. We're skipping the calculator question. So don't work ahead. Make sure everybody at your table has all of the answers. You gotta work on it. Some of you slower than others. That's okay. We got everything at this table? People? You got everything? Yeah? All right, here we go. I'm going to call on a random person from a random table. I'm assuming everybody's got all the answers. Evo, hit me up with the -4s. 2, 2, 2. Undefined for function values. I would accept either answer, however, on your quiz. What? Function values are defined or undefined. Limits exist or do not exist. Okay? We don't have a point at -4, but really close to -4, I'm approaching that location. Holes have limits. All right, back to King's table. King, what do we get for the next row? That's you, King. You're good.
4, -2,
Perfect. To the left, I'm using the red piece. To the right, I'm using the blue piece. I'm approaching this point. I'm approaching this point. At the location at 1, I'm using this piece. I'm using the 0.14. But the left and the right don't equal each other. This does not exist. This makes no effect on this. Switching over to Abernathy, your table. What do we get for the 6s? You guys are experts. 5, 5, 5, and 2. To the left and right of 6, I'm using this piece. I'm approaching that y-coordinate 5, but at 6, I get 2. If you got that right, everybody, good. If you don't, if you didn't, it's okay. Let me just tell you one thing. In this class, it is not about memorizing how to do things. This is very important. Everybody's listening, right? If you try to memorize how to do every single problem in this class, you're going to really struggle throughout the year. But if you work on understanding why we do what we do, you understand why we are taking these steps, that's what's going to lead you to success. The whys are what I teach and what I expect you guys to try to understand. All right, here's a multiple choice AP question. Yo, if you got through your past math classes by like, I did the review and I memorized what to do, change your mindset. This is a different class. Okay? You need to understand the content. You're not going to be able to look at a review and memorize things. You're going to really struggle if you do that. All right, this is a multiple choice question. This is from an AP exam. What's the answer, A, B, C, or D?
Yeah, bro.
You got it, Chevette?
I think so.
Yeah, you did.
Should I just trust all this? Knowledge. Should I beat the
Burns.
You're wrong, but you are.
Sorry, Burns. Good job, Burns. Miller. Nice. Jennings. Good.
Oh, yeah, no, you're wrong.
Hensley. Good. Are you the better Hensley? Oh, nice. I'll tell you something. B is the answer. As x gets close to 9, y's are getting close to 5. Now, another question I would ask is like, hey, write a statement for this. Write a statement for this. Write a statement for this. Could you do it? Good. This is the opposite. As x approaches 5, it'd be 9. As x approaches 9 from the left, I get 5. As x approaches 9 from the right, I get 10. As x approaches 9 in general, does not exist. As x approaches 9 from the left, I get 100. Maybe. I don't even say I get 100. This is a probably I don't get anything. We haven't really talked about that with like asymptotes. We will. But here, if I said x approaches 9 from the left, I would say that probably doesn't exist, or we are growing towards infinity. We will get there on lesson 3. Don't worry about that one. All right? Now, I'd like you to skip the calculator questions, and in your homework, there are calculator questions. You may skip those. I did them in the homework video, but in hindsight, you don't need to do them. You will not be using your calculator. But we are going to replace these questions with other questions shortly. Cool? Cool. Kremley. The use your calculator questions. All right, now we're over here. We got a little bit more to do. Ready? Here we go. These appear different and crazy and funky. But if I said f of x equals x cubed plus 2x for all x's. Now this is still in the notes. And I ask you, what's the limit as x approaches 2 of f of x? This is the same question. Are you following? If I ask you this question, it's the same as me giving you the function and then asking you, what is the limit as x approaches 2 of the function? Now you might think, okay, I got to plug in 1.99999. I got to plug in 2.00001. Both of those numbers are close to 2. I'm using this function for all numbers, including 2. Well, tell your neighbors, what's the answer? Yeah, just plug in 2. If there's nothing crazy going on, if you don't get a 0 over a 0, then you don't have to worry about factoring or doing anything crazy. You just plug in 2. Try to plug in 2. If you don't get 0 over 0, that's your answer. If you get 0 over 0, or you get a 0 in the denominator, more inspection is needed. Yeah. Question? Or are you just doing it? Cool. Just plug in 2 pi over 3. If you don't get 0 over 0, you're good. You get a number, that's your answer. Just plug in 2. Cool, e squared. E squared's an answer. Don't try to worry about getting decimals. Now, wait, hold on. What about this next one? Limit as x approaches 3 or 4. Ooh, limit as x approaches 3 or 4. What's that? Plug in 3. I can't plug in 3 anywhere. What's the answer? If it does not exist, well, yeah, I don't know. Stevenson, what'd you get? Why? Why is 4? At 3, you get 4. At 7, you get 4. At -2, you get 4. That's what you get. You're right, Stevenson. It just is. Now, please go back to the parts that we crossed off. And please replace the questions that we crossed off with these questions. These are not in your notes. Go back to the using calculator questions in your notes. We're going back a page. These are my notes. I get to do whatever I want with them. You crossed off the calculator questions. Please enter this question. The whole using your calculator you crossed off, you are replacing on the top right this question. Limit as x approaches 4 of x minus 4 over x squared minus 16. I got 4 minutes to do this, and we're going to do it. Following? We're here. Hold on. I thought I had 2. Hold on. The last couple questions we wanted to plug in 4. Okay, we always like to try to plug in the number. I plug in the number, I get 0 over 0. Does that mean this does not exist? No. This means we have a hole. The answer is not undefined. Holes have limits. This is the situation where, I can plug in 3.99999. And when I plug in 3.9999, I won't get 0 in the denominator. Instead, what I will get is 1 over 8. Yeah, those you have to, like you did it well on the examples earlier, but then we messed up at the end. Make sure you do your homework and you understand.
And what about the rest of the notes?
We get them. You'll be fine. We did everything that we needed to do with me not feeling bad about it.
Are these 2 questions part of the no calculator section?
No.
Okay, awesome.
For this one, you can factor as well. If I plug in 0, I get 0 over 0. Don't plug in 0 though. 0 over 0 is an indication we have a hole. We can plug in any other number. Because if I plug in any other number,
Because it's the general limit.
well, to get a general limit, you got to look to the left and to the right. If I look to the left and to the right, I will not get 0 in the denominator. I'll get something close to 0. I get negative 2/3. Please return your chairs. Who is this?